So I'll start by taking questions from this previous assignment.
What's that one called?
This is properties of logarithms.
Oh, it's not like 4 or something.
Oh, it's 5.
Oh, okay.
Callie.
Number 5.
So this is an expanding problem. The order and properties that we use for an expanding problem is quotient, product, power. So I notice there's a quotient property going on because I have division inside the logarithm. So the quotient property allows me to rewrite that as the difference of two logarithms. There is no product property because I don't have any multiplication going on inside either of these two logarithms. But I do have a power property because I have an exponent on my 2. So if I use the power property, I can move that exponent to the coefficient. And that's my answer.
What's a minus?
The quotient property.
Oh, okay.
Remember from last time
Yeah.
is means subtraction. Right.
Okay, yeah, I just forgot about that.
No problem. Anybody else with questions? Woody?
25.
Okay. So 25 looks bad, but depending on how you do it, it could be not that bad. What I would do first is to kind of get rid of these parentheses by distributing. That includes the negative sign. And now since we're condensing, the order we do is power, product, then quotient. So I see I have 3 power properties, because I have coefficients here, here, and here. So with this first power property, I have to be a little bit careful, because that exponent is going to apply to everything inside the logarithm. So I'll use an extra parenthesis there, but the other 2 are no big deal. Okay. Then we're going to look for our product properties. There's actually 2 product properties here that are hiding. So what I'm going to do here is I'm going to factor out that negative sign. And then it's obvious that there are those 2 product properties there. These are the 2 addition symbols. Notice on that step I also simplified 2x squared to 4x squared and 5 squared to 25. And then I'll apply my product property. So 3 times 25 is 75, and then the y squared. And then my last step is to do the quotient, since I have that subtraction there. So log of 4x squared over 75y squared. And that's my final. So as long as we started by kind of clearing those parentheses out of there, this kind of went, you know, basically like one of the problems we did in the example, right? Wasn't anything wicked different there. Allie?
Will we get to use a note card again? Or like
haven't written the test yet, but if you remind me next week on our review day, we can certainly talk about it. What's next? Kelly? Okay. So again, this is a condensing problem. So the order that I'm going to do my properties is power, product, quotient. So I see that each of the logs has a coefficient there, so I'm going to do the power property. Then that's going to move the coefficient to the exponent. I don't have any product properties because there's no additions. But I do have a quotient property because of the subtraction. So that's going to be log of u to the 4th over b to the 20th. And that's it.
Oh, that's not bad.
Nope. What do you?
26.
Okay. So the trick here is to remember that log of 2 is just a number. So if I look at this right now, this is a power property situation. So either I would do this, or we would do this, right? It's ambiguous as to which one you would do. Both is correct. I think this one would likely be the one that would be more useful if you were going on later to do something, because having a variable or having a number in your exponent is easier to deal with than having the variable up in there, but that's it. Okay. Today, we're going to talk about solving. And there's two types of solving problems that we're going to talk about. We're going to talk about solving exponential equations. And then we're going to talk about solving logarithmic equations. So we're going to start with the exponentials first.
Can I turn the lights off?
Sure. So let's say that we have a problem like this. So I have 4 to the x minus 3 equals 8 to the 2x minus 5. So the first thing that I'm going to notice is that the base of my exponentials is not the same number. But if I look at those numbers 4 and 8, I notice that if I do a prime factorization on these, they would turn into an exponential with the same base, because 4 is 2 squared, and 8 is 2 to the third. So that's what I'm going to do here first. So far, so good. So now I have these exponents of an exponent, right? I have 2 squared to the x minus 3, and I have 2 to the third to the 2x minus 5. How do I simplify an exponent of an exponent? That was one of the properties from last chapter. They multiply. And then I can just kind of distribute things through. Now, if I have some power of 2 that is equal to some other power of 2, what can I say about the powers? They have to be equal, right? If I have 2 to the third equals 2 to the something, the only thing that something could be is to the third, right? If they're equal. So that just allows us to drop the exponent bases. And now, like, I can subtract 2 from both sides to get 4x, and add 15 to both sides to get 9. And if I divide both sides by 4, I get x is equal to 9/4.
That's all you do.
For that one. Okay. So that one's fine, right? No big deal. The natural next question should be, okay, Mr. Kulik, but what if I have 2 exponentials that are equal, and I can't, at least in an obvious way, rewrite these so that they have the same exponent base? Right? 4 is 2 squared, but 6 is 2 times 3. They won't have the same base even after we factor them. Do you guys see that? So what should I do in this situation? Well, in a situation like this, I need to use a logarithm. Now, there's lots of different logarithms I could use. I could use log base 5, I could use log base 7, I could use log base 3.26. The question is, which logarithm should I use? Well, the answer is it doesn't really matter, but you can make the problem easier if you choose one of 2 logarithms to use. So the best 2 to use would be log base 4 or log base 6. Now, it doesn't really matter which one of those 2 you use. They save the same amount of time for the same amount of work, but those would be the best 2 options. Although any logarithm will still be okay, it just creates a little bit more work. Is everybody so far so good? So for the sake of argument, let's choose log base 4. So I'm going to do that to both sides of my equation. Oh, hang on to your tablet. I'm just making notes. I can't tell if you're smiling or not because you're wearing a mask.
They're smiling.
I mean, I'll buy that you're smiling, but I think that's probably the case most of the time. All right. So, if you remember back to, I don't know, 2 lessons ago, one of the big ideas was that log base b will cancel exponent base b. So in this case, by choosing log 4, or log base 4, we are able to cancel the exponent base 4. And we're left with just what was in the exponent, the x minus 3. Now the same thing isn't going to happen on the other side, because the base of my logarithm doesn't match the base of my exponential. But what I can do is apply the power property that allows me to move the exponent to the coefficient. So far, so good? Now remember that log base 4 of 6 is just a number, right? Now it's a crummy decimal, but it's just a number. If it makes life easier for you right now, you can trade out that symbol for its decimal. That's okay. So let's type into our calculator log base 4 of 6.
How do you get the button where you put the base in? Yeah.
You press math, and then it's down at the bottom. Almost, it's off the screen, you have to keep scrolling.
That makes sense.
And that number is about 1.292. So then I can just kind of distribute that in. So I have 1.292 times 2 is 258.5. And then that number times 5 is 646.2. I'm sorry, 6, 4. I'm going to get it. I just already confused myself. 64.62. Everybody so far so good? Okay, now we'll just solve for x. So I'm going to subtract 1x from both sides. That'll give me 1.585x. And then add 6.462 to both sides. That'll give me 3.462. And then I'll just divide. That gives me 2184. What is what?
No, what's a bad? Like, what is that, like, in the box? 2184 what?
That's
Well,
the
that's a rough.
squiggly because we rounded.
Yeah. Nice top one. What is that?
Yes, Megan?
So, subtracted the x and added the 6. I never want to get a work yet.
That's exactly right.
I hated that class so much. Yeah, so hard.
Okay, so I want to point something out to you. This method that we just did, where we took the log of both sides, could you have done that in part A?
Yeah.
Yes, right? That method would still work in part A, or in number A, letter A, example A. Right? You could do the log to both sides and it would still work the same way. It's a little bit of like overkill, you know, like using a baseball bat to squash a fly or something, but like, you know, it'll work. We'll do one more exponential example because there's one more kind of situation that you might run into in your homework. For me, I mean, there's lots of other situations, but for this class, with the work that we're expecting you to do, there's really only one more kind of problem I want to talk about. So let's say I have negative 2 times 3 to the 4 minus 5x plus 10 equals 6. So here, notice I have only one kind of exponential, right? As opposed to the previous problems where I had 2 different exponentials. But I have some other stuff that's not exponential in the problem also. Everybody's okay with that plan? Or that difference between the previous examples and this one? Okay, so our plan is going to be to isolate the exponential part. So to do that, I'll subtract 10 from both sides to start. And then we'll divide by negative 2. And now this problem is basically an easier version of example B.
Oh, okay. Just kidding. I thought that was a decimal. So I was like, how do you divide by? But I'm good.
Oh, yeah, it was a time symbol because I got to put something there.
That makes sense.
I didn't want to use an X because we have an X in the variable.
No, yeah.
So like, I used the dot for the time symbol.
I was like, how did you do that? Alright, I'm done. That was it. I thought it was decimal.
We'll do that. That looks a little less decimal-y. So, to solve this, I'm going to use a logarithm. Where we're at now. Which logarithm would I want to use?
Log base 3.
Good. Log base 3. I want the logarithm whose base matches the base on my exponential. Yes, sir. Yes, sir. And the reason we wanted to use log base 3 here is because we know the log base 3 cancels exponent base 3. And now we know log base 3 of 2, that's just a number, right? It's a crummy decimal, but it's just a number. It's something we could type into our calculator. So let's go ahead and do that. So 0.631. So then we can like subtract 4 from both sides. And then divide by -5. And that'll give us 0.674.
Feels really not too bad. Like, once I actually pay attention, like I know how to do it.
This chapter tends to be I get it or I don't.
Yeah, like I don't think it's that bad.
Because it's the logarithm is like a weird thing, but if you can accept that it's just a symbol for a number, and you realize you can remember that like the logarithms cancel exponent bases and exponent bases cancel logarithms, it's usually not too bad. If you can keep that together, the rest of it's pretty similar to all things that we've been doing the whole semester. So
I think this is like one of the hardest ones, but one of the hardest chapters. But
what I would say is that the concept here is one of the more difficult concepts conceptually. The actual problems I don't think are that difficult. I think the problems in last chapter are actually the most difficult problems that we do. But they are, conceptually, it's a rather easy chapter. That's my opinion anyways. Like some of those simplifying radical expression problems can be very difficult. But the concept of a radical is not difficult to understand. Here, the concept of a logarithm is kind of difficult to understand, but the problems themselves are not as difficult. Yes?
Can I get to the bathroom?
Of course. So let's say we have a problem like this. So this is a logarithmic equation. Notice I have just one logarithm in this equation. So my goal is going to be to get the one logarithm by itself. That's going to be my first step. So first thing I want to do is subtract the 8 from both sides. And then divide by the -2. So far, so good. Now the logarithm is alone on the left side of the equation. So what I want to do is I want to cancel that logarithm. To cancel that logarithm, I need to use an exponent base. Which exponent base should I use? Should it be 5? Should it be 2.6? Should it be 1/3?
10.
Should it be 10? How did you come up with 10, Woody?
That's the normal one.
Yeah, so the common log, when we write log with no base there, we've agreed that we really mean is log base 10. I'm going to write my exponent base big, so there's no way I get confused and think, oh, I'm multiplying here, right? We're not multiplying. That's the base of an exponential, that number 10. We're not multiplying both sides by 10. So exponent base 10 cancels log base 10. So I'm left with just a 2x minus 6. And then 10 squared is 100. So then I can just add 6 to both sides. And then divide by 2. To get x equals 53. But we're not done. Logarithmic equations can have extraneous solutions. So before we're done, we have to go back and check. But the check is quite easy. All we need to do is make sure that when we plug x into the logarithm, we don't get a non-positive number. So we just have to make sure that 2 times 53 minus 6 is a positive. It definitely is. So that answer is fine. We just can't have 0 inside a logarithm, and we can't have a negative inside of a logarithm. So that's all I need to do on my check, is just to make sure that I'm not getting either 0 or a negative inside any of my logarithms. But that one was fine. Okay there? Again, that shouldn't have been too bad. So let's look at our next example. Here we have log base 2 of x plus log base 2 of x minus 2 is equal to 3. Notice in this problem I have 2 logarithms and something not in a logarithm. Right? I have log base 2 of x, and I have log base 2 of x minus 2, so I have 2 logarithms. And then I have it equal to 3, a non-logarithm. Everybody cool with what we're looking at there?
Yes.
Okay, so my goal to start with in this kind of a situation is to condense my logarithms into a single logarithm. So just like last night's homework, we're going to condense those. If I look, the only thing going on here is a product property, right? There's no coefficients, there's no subtraction. All I have is one addition symbol. So I'm just going to use the product property to condense those. And at some point, I'm going to need to multiply inside of that logarithm. I might as well do it now, just to multiply that stuff out. And now this step is just like the previous problem, right? Because now we're down to one logarithm, just like we had before. Bad dreams. So how did we cancel out? How are we going to cancel out this log base 2? An exponent base 2. Very good. And the reason we pick exponent base 2 is because that one specifically cancels log base 2. Let's write just, instead of 2 to the third, I'm going to write 8. So what kind of an equation are we now left with?
Just finish off the x's.
Well, not exactly, because this is a
root.
quadratic equation.
Yeah.
So to solve a quadratic, first things it needs to equal 0.
You are correct.
So we'll subtract the 8 over. And then to solve this, the 2 ways in particular we talked about was to either factor or use the quadratic formula. Now this one, where the leading coefficient is 1, I'm going to try to factor it first, because if I can, it's usually going to be quick. If I can't figure out how to factor it, I would definitely use the quadratic formula, because maybe it's not factorable. That can happen. Or maybe I just am having a moment and can't figure out what to do. Either way, the quadratic formula would work there. But I do remember how to factor, and this one does indeed factor, so I'm going to use that. The 2 things that multiply to give me -8 and add to give me -2 are?
4x plus 2.
-4 and 2.
I just did that.
Good. And then when I set each of those equal to 0, I get +4 and -2 as my answers, right? But
It's a check.
we're not done. We have to go back and check. So if I go back with 4 to the original problem,
Oh, yeah.
if I plug 4 into x and x minus 2, both of those would give me positive numbers, right? I'd have log of 4 and log of 2. Both of those are fine. If I go back and look at -2, though, if I plug -2 in here, I get log of -2,
That's not right.
and that's not okay. So that one is extraneous,
And you
So you can't have negative logs.
no, you can't, or 0.
or 0.
You have to have positive number.
You have to have a positive number inside the logarithm. That is correct.
So I would just plug in log 2, 4. Log base 2, 4. To check it.
No.
No, you don't even need to find the number. All you have to do is make sure the stuff inside the logarithm is a positive number.
What's the
The
stuff
stuff
inside?
inside the parentheses, like,
So like
so-
when I plug 4 in here, I
This
get
is 4.
4. That's positive.
Oh, okay, yeah.
When I plug 4 in there, I get 2. That's positive.
Yeah, that makes sense.
That's all I need to do to check. I don't actually need to show the 2 sides are equal. It's okay to do that,
that's a work.
but that's more than you need to do, right?
Sounds good.
These checks you can just do in your head, right? You don't actually have to type anything into your calculator and pound it out. You can if you want to. It's not wrong to do that. But it's not necessary. Everybody okay with that one?
Yeah.
Okay. One more example. Okay, so let's say we have the natural log of 2x minus 3 equals the natural log of x plus 4. Notice this problem we have only 2 logarithms, right? There's not any other non-logarithmic stuff like there was in the previous problem, where we also had that 3 rattling around. So this situation is actually the easiest one to deal with, because what we basically have here is the same idea that we had here, where we had 2 exponentials with the same base, where we could just drop the bases and set the exponents equal to each other. Right?
Yes.
You guys see that?
Yes.
If we have 2 logarithms with the same base, we could just drop the logarithms and set the insides equal to each other.
Wait. Is ln the same as like the log, right?
Ln is the same as log base e.
Yeah. What does e mean? Why would you just
E
say
is
log
that
base?
number 2.71828, yada, yada, yada.
Why would you just say log base e then?
Because there's these two logarithms, the natural log and the common log, we use frequently. And so we've abbreviated them. Just like we don't write a 1 in front of an x,
Oh, yeah.
or a 2 for the index on a square root. Like we just do this in mathematics. We decide the stuff we use all the time we're going to just create a shortcut on. So that's what's going on here. Anyways, from here it's easy. We subtract x from both sides and add 3 to both sides, and we get 7. And if you plug that in, 2 times 7 minus 3 is definitely positive. And 7 plus 4 is definitely positive. So that answer is good.
Oh, it's easy.
That one is usually the easiest situation because you can just forget about the logs and just go on about your business. Okay. Is everybody okay?
Yes.
All right. This is where we're going to stop.